Hello students. Welcome to the YouTube channel, Physics Simplified. Here, we will understand numerous concepts of physics from a numerical perspective. So, without any further delay, let's jump into the discussion. Topic of discussion for today's video: magnetic field due to a current carrying curved wire segment. This is one of the numerous applications of Biot-Savart law. In this problem, we have a current carrying wire segment which is carrying a steady current. As shown in the figure, the wire segment contains two straight portions and a circular arc. The arc subtends in angle theta at the given point where we have to find the magnetic field due to the current carrying wire segment. The radius of the circular arc is also given. Let us now identify the concept we need to solve this problem. Whenever current flows through a given wire or a conductor, we can consider that as the current segment. Every current segment produces magnetic field around it. Before finding the total magnetic field at a given point produced by the current segment, first we need to find the magnetic field produced at the given point by an infinitesimal current element of that segment. This can be done by using the expression of Biot-Savart law. Vector dB is equal to mu0 by 4 pi times I vector dl cross r hat divided by r squared. Here vector dl is the vector length of element of the wire carrying the steady current, while I times vector dl is the current element of the wire. Remember, r hat is the unit vector from the current element to the given point. Now, we will set up the procedures in final equation to solve the problem. We will consider the two straight segments of the wire, PP' and QQ' first. It must be noted that the magnetic field at point O, due to the current through these straight segments, is 0. This is because, for both these segments, vector dl and r hat are parallel to each other. So, if we carry out the cross product of vector dl and r hat, the result will be 0. Hence, we can expect that the total magnetic field at the given point O is only due to the flow of current through the curved portion of the wire. So, we need to apply the Biot-Savart law to calculate the magnetic field at point O due to the flow of current through the curved portion, that is, PQ, of the wire. Before progressing further, let us note down some important information related to the curved segment of the wire. As is evident from the figure, distance of each of the vector length element, dl, along the curved path PQ, is the same, and is equal to A. Current in each element contributes a field element, vector dB, at the point O, directed into the page. The direction of the field can be obtained by using the right-hand rule of the cross product for vector dl and r hat. We also find that every point on PQ, the length element vector dl, is perpendicular to r hat. So, we find the magnitude of the cross product of vector dl and r hat to be equal to dl. Let us now find the magnitude of the field at point O due to the current I in any one element of length dl of the curved portion PQ. This is given by dB is equal to mu0 by 4 pi times I dl divided by A squared. Integrating this expression, noting that I and A are constants over the curved path PQ, we get the total magnetic field at point O, which is given by B is equal to mu0 by 4 pi times I divided by A squared integral dl. This is equal to mu0 I divided by 4 pi A squared times L, where L is the length of the curved segment PQ, which is a circular arc. By using the relation angle equals arc length by radius, we can express L in terms of A and theta. The relation is given by L is equal to A times theta. Substituting this relation and simplifying the expression of B, we get the total magnetic field at point O which is given by B is equal to mu 0 I divided by 4 pi a times theta. This is the answer to the problem. This magnetic field at point O is directed into the page, and this is symbolized by encircled cross.